Okay, 73 wants us to graph two equations, right? So the two equations, here's 1, here's 2. So they're both in slope-intercept form. So let's graph number 1 first. So the y-intercept is 3 because it says 2x plus 3. 1, 2, 3. And the slope is 2. So down to, right, over 1, right? Or up to over 1, right? So there. So that graph, and again yours will be straighter, looks like this. That's graph 1. And the second graph, graph 2, y equals x plus 1, the y-intercept is at 1. And the slope is 1, up 1 over 1, up 1 over 1, right? So it goes like this. So this one goes up that way. This one goes down here. So this graph, the left one is y equals 2x plus 3, y equals, and the right one is y equals x plus 1. And the point of intersection is kind of hard to see, right? But it's right here. And again, your graph will be more accurate than mine. And we could find that point of intersection, right? It doesn't ask us to do it, but we could do it, right? Equal value methods. We could set 2x plus 3 equal to x plus 1, right? And subtract x from both sides. And get x plus 3 equals 1. Subtract 3 from both sides. Get x equals negative 2. And then substitute into one of the equations. So I'll substitute into y equals x plus 1. So y equals negative 2 plus 1, y equals negative 1. So they intersect at negative 2, negative 1. And that's pretty close, right? If you were using a straight edge, it would be exact. But there's the actual point of intersection, negative 2, negative 1.